Hey guys, how's it going? It's day 15 of 100 and we are still under the basic JavaScript section. Objects were giving us a bit of a hassle and I decided, you know what? I'm not going to stand for this. I'm not going to let the objects bully us. So I took a few hours and I went through objects to get a better understanding of how they work, especially considering how important objects are in JavaScript. And I learned quite a few interesting things. I learned about methods, how you can call them, basically functions in an object. I learned about the constructor, how you can create basically a new object that gets inherited properties from the parent, and a few other things, and it was pretty exciting. I feel it's going to give us the advantage we need to continue. And I'm looking forward to see how far we can get with that. Cool, so let's continue with where we are now. Because this should be quite exciting. And that is generate random fractions. Generate random fractions with JavaScript. Random numbers are useful creating random behavior. JavaScript has a math.random function that generates a random decimal number between 0, inclusive, and not quite up to 1, exclusive. Thus, math.random can return a 0, but never quite return a 1. Can you imagine? Because I wonder if it ever can if you do like a million iterations. Like storing values with the equal operator, all function calls will be resolved before the return executes. So we can return the value of the math.random function. Change random fraction to return a random number instead of returning 0. So we're going to return math.random. That was simple enough. Generate random whole numbers with JavaScript. It's great that we can generate random decimal numbers, but it's even more useful if we use it to generate random whole numbers. Use math.random to generate a random decimal. Multiply that random decimal by 20, and then use another function, math.floor, to round the number down to its nearest whole number. Remember that math.random can never quite return a 1, and because you're rounding down, it's impossible to actually get 20. This technique will give us a whole number between 0 and 19. Putting everything together, this is what our code looks like. Math.floor, math.random times 20. We are calling math.random, multiplying the result by 20, then passing the value to math.floor function to round the value down to the nearest whole number. Use this technique to generate and return a random whole number between 0 and 9. So we're going to do math.floor, math, I should probably add an extra O in there, math.floor, math.random, and number between, oh right, times 9, because it needs to be anywhere between 0 and 9. Just want to check real quick. Wait, why have I got a 1 there? I meant to have that there. I think that should be all that we need. What are we missing? Let's see quickly. Oh, I need to return it, not My bad. Sorry. That should be it. Oh, it has to be between 10, not 9, because you want a value between 0 and 9. There we go. What if it actually did get to 10 though? Wouldn't that be something? Generate random whole numbers within a range. Instead of generating a random number between 0 and a given number like we did before, we could generate a random number that falls within a range of 2 specific numbers. To do this, we'll define a minimum number, min, and a maximum number, max. Here's the formula we'll use. Take a moment to read it and try to understand what this code is doing. Math.floor, math.random, times max minus min plus 1 plus min. Okay, so we got max, let's say it's 10, minus min, which is, let's say, 4, which would be 6 plus 1 is 7, plus min. Create a function called randomRange that takes a range mymin and mymax and returns a random number that's greater than or equal to mymin and is less than or equal to mymax, inclusive. Okay. So we're going to return math.floor math.random times takes a mymin. Did we define mymin? Ah, there it is. You're already passing it. Mymin, oh sorry, take the largest one, mymax minus mymin plus 1 greater than or equal to, so that means plus my min, because then that's greater than or equal to my min, so it'll always be at least whatever that is plus my min, and is less than or equal to my max. There we go. Wonderful. Use the parseInt function. The parseInt function passes a string and returns an integer. Here's an example. var a parseInt 007. The above function converts the string 007 to an integer 7. If the first character in the string can't be converted into a number, then it returns NaN for not a number. Use parseInt in the convert to integer function, so it converts the input string into an integer and returns it. So parseInt string. Oh, and you want me to return parseInt string. Not part. ParseInt. ParseInt. There we are. Oh, good. Use the parseInt function with a radix. The parseInt function passes a string and returns an integer. Hold on. What about the radix? The parseInt function passes a string and returns an integer. It takes a second argument for the radix, which specifies the base of the number in the string. The radix can be an integer between 2 and 36. The function call looks like this: parseInt string and then the radix. And here's an example: var a parseInt 11 radix of 2. The radix variable says that 11 is the binary system, or base 2. This example converts the string 11 to an integer of 3. 0, 1 plus 1. 3, yeah. Interesting. Use parseInt in the convert to integer function, so it converts a binary number to an integer and returns it. Binary. Okay, so 2. You happy with that? Yes, you are. Use the conditional. Ooh, finally we're gonna learn this exciting thing, which I've seen many times before, but I haven't quite understood it. So let us get it in. Use the conditional ternary operator. The conditional operator, also called the ternary operator, can be used as a one-line if-else expression. The syntax is condition, statement if true, statement if false. The following function uses an if-else statement to check a condition. If a greater than b, return a is greater, else return b is greater. Whereas you could just be rewritten with return a greater than b, a is greater. So the first one is if true, otherwise if false. That is so much easier. What? How? I love it. I love it. So this is how you could go and refactor your code. Because jeez, you save 3 lines from 1, 2, 3, 4, 5, 6, 7, 8 lines. Wow. That's like a reduction of 5 lines of code. That's amazing. That really is amazing. Use the conditional operator in the check equal function to check if 2 numbers are equal or not. The function should return either true or false. So ternary. Okay, wait, I just got to double check how. So the condition. Return a is that part of the condition? They didn't explain that. Is it a and then b? This is a, this is b, or true and false? Or is it, oh, that's the if, that's the condition, right? So we pretend this is an if right here. If a greater than b, a is greater, else b is greater. So we want to check now if 2 numbers are equal or not. So it starts with a return and then the if, which is a equal to b, then the question mark. Well, it's like asking a question. That's how I can remember it. It's like, ask your question. What is your question? Ask the question. Then what's the true? If it's true, what do you say? The function should either return true or false. True. Otherwise, is it a colon or a semicolon? It's a colon. Okay. And I don't need to do true as a string. I can just literally return true, otherwise false. And to see what it does, we can do console.log. And if we change 1, 2 to 2, 2, it should say true. Oh, that is so cool. I love that. This makes me really excited, especially to build other things that I have. So return, and then we're checking if it's exactly equal. Value if true, value if false. I should start making notes, shouldn't I? What do you call it? the ternary. Oh no, way to go. Cool, that's something to remember. Let's move on. I'm just making a note as well that I learned about methods, which are functions inside an object, such as document.write. Write is a method of the document object. That was something cool that I learned. It's nice to keep these notes. I'm sure I'll remember, but in the case that I don't, the important stuff, the big stuff to remember, it's nice to have those notes so that you can just check them. Okay, so we should be able to run this and all should be well. Use multiple conditional ternary operators. In the previous challenge you used a single conditional operator. You can also chain them together to check for multiple conditions. Okay. I was wondering how it works with if, else and all that. The following function uses an if, else and else statement to check multiple conditions. The above function can be rewritten using multiple conditional operators. Which is A equal to B? That's the question. A and B are equal, if it's true. If it's false, you ask another question. Is A greater than B? If true, A is greater, B is greater. Okay, that's something to also make a note of. Can also have multiple use multiple conditional ternary operators. Okay, so we've done that. The above function, yeah, so we understand how that works. So it's the first question. If it's true, else whatever is afterwards, it's false. Use multiple conditional operators in the check sign function to check if a number is positive, negative, or zero. So ask the question. Check if a number is positive, negative, or zero. So number greater than, if it's greater than 0, you ask the question. num greater than 0, value if it's true, now what do you want me to return? Because it didn't specify what I need to do. Okay, it says at the bottom. So it should say positive, otherwise num num less than 0, question. If that's true, it's negative. Otherwise, if it's false, it's going to be 0. And I don't think we need to add a check or whatever, because if it's greater than 0, positive. If it's less than 0, it's negative. So what else could it be? It must be 0, right? And that should be all. Yay! Christopher S! How's it going? So good to see you. It's really great to have you here. I hope you're doing well. How are things going your side? Oh, this is so exciting! Introduction to the ES6 challenges, and we're gonna be able to use let and const. Oh, yes! No more vars! Then people can stop asking me, why are you using var? What are you? Like a caveman? Oh, this is so exciting! Christopher's, what did I want to say? Oh, so, yeah, you know the objects were giving me hassles? And the thing is, I guess it's also a bit harder for me to study while I'm trying to read it out, because I kind of have to, I don't want to say like entertain, but at the same time I am reading it out for the stream, and it makes it a bit harder to focus. So I'm like kind of reading it out, trying to focus on chat and this and that, so you don't take that much in, even though a few times I do, and that's especially why I love it when you guys help me in chat and, you know, answer the questions, because that way then I do learn. So last night and a bit today I decided to look up objects, obviously off stream, because I felt I could like just focus a bit more, and I feel that I have a much better understanding of objects now. Like if I had to go back to yesterday's section, I could probably do things way better. And I learned quite a few things, such as methods. I finally understand methods are functions that belong to an object. So for example, document.write. .write is a method of the document object, because pretty much everything's an object in JavaScript. And I realized it's the most important part, and if I can't grasp that, then, you know, I'm gonna really struggle. And that was really exciting. Like, I had no idea. So you can literally have an object and it can have properties. That's another thing that I finally understand the relationship with the key value pairs, is that objects obviously have properties, and the properties link to a value. And arrays, I forgot the exact term, but you can't have, I can't remember what the name was, but basically you can't have arrays that are named. Arrays can only be number based, whereas if you need another pair that uses a string, you would then use an object, if that makes sense. Like, that's the way that I understood it. So arrays have to be numbers, because JavaScript doesn't support anything other than numbers in an array. And if you need the other use that other languages support, like in Python, then you're going to have to use an object. And yeah, that was really cool to see how functions can be like, that blew my mind, like that I saw a function in an object. And then it made sense, and that's why you'd use the this keyword, because then you can take whatever the parameter is, or rather the argument you pass in, you use this dot whatever that parameter is, and you can use that in a function to like update, let's say, that property's value. So that was cool. But yeah, that's pretty much what I covered, the most important parts. I also got a better understanding of the object notation, and if I use a variable that I have to use bracket notation, because dot notation is going to be literal and it's going to look for exactly that name. So that was good to go through, and yeah, just overall I feel a lot more confident with objects, and in good time, because now we're going to do the ES6 challenges. Wow. And I heard of promises. This is gonna like freak me out a little, because I know nothing about promises and classes, which doesn't really exist in JavaScript, but it does in ES6. Whoo! So that was that, huh? If I'd known that it was just 26 more minutes, I would have continued last night, but I guess I needed that little break, because now we're doing ES6. So I wonder if I should just split the stream here and start a new stream. Can't remember that promises were in this section. Yeah, maybe it's something new they added. I know they keep adding things. That's gonna be fun. But I think I'm gonna end the stream here just for continuation, so that we know that that was that, and I'm gonna do ES6. So the stream's gonna be right back. I'm just gonna switch over, and I will see you now. I'm so excited for this. Yay! I'll see you now, Christophers.